Now let's discuss this problem. Del u by del t is equal to del square u divided by del x square x into e to the power t minus 2, t less than 0, 0 less than x less than pi, and u0t minus t square u pi t pi comma t pi e to the power t u x comma 0 sin x minus sin x is cube sin cube x, and this is which of the following is true. So friends, whatever you see that I can write v0 t equals to construct a function that is u0 t minus plus t square. I can write that is this value is 0, v pi t v pi comma t v x comma 0 plus equals to sin x is equal to u x comma v pi t. Sorry, this is not this way. This v pi t equals to pi comma t equals to 0, and v x comma 0 equals to u x comma 0 plus x equals to sin x minus sin cube x. So it can be written 1/4 plus sin 3x 1/4 is equal to sin x plus 3 sin x minus 4 sin cube x. It can be written sin x minus sin cube x. So del p by del t, I can write this way: del p by del t equals to del u by del t, del u by del t plus x into e to the power t plus 2t equals to del square u divided by del x square. So del square del x square equals to del square u divided by del x square, or del v by del t del square v divided. This is my equation. So del v by del t x square can be written 1/4 e to the power minus t sin x plus e to the power kt sine 3x equals to 1 by 4 to hence this way. So this is my possibility, and this option this option is wrong. Now next we will go to solve another problem. Consider the ODE equals to y dash equals to y into y minus 1 into y minus 2. Which of the following is true? If y0 is equal to 0.5, then y is decreasing. If y0 is equal to 1.2, then y is increasing. Then y is unbounded, y is bounded below. Let's try y dash equal to y into y minus 1, y minus 2, dy divided by dx equals to y into y minus 1, y minus 2. So dy divided by y, y minus 1, y minus 2 equals to dx. So my value will become dy divided by 2y minus integration dy divided by y minus 1, just partial break, and plus 1 by 2 into dy divided by y minus 2 equals to x. That implies half into log y log mod of y minus 1 plus half log mod of y minus 2 equals to x. Log of root over y into y plus y minus 2 divided by y minus 1 mod of is equals to x plus c. Now root over y into y minus 2 divided by y plus 1 is equal to e to the power x plus c, and let's draw a graph y into y minus 2 less than 0. The possibility is 0, 0, 2, minus, plus, and this is 2, y less than 0, y less than 2. Number 1 is not correct because y equals to 0, it is 0.5, then y is decreasing, this is not possible, and number 2 is that this is not possible, increasing decreasing is not increasing function, it's not decreasing function in this region. So number 3 is correct. If y equal to y0 2.5, then y is unbounded. It's not possible. This is the way. Next problem is the integral solution. Yx is equal to 3x square. So I can write 3x square into convolutions from yt star sine yx comma sine x. This way L yx equals to 3 and L square plus L sine x L yx. This value is y bar s 3 into 2 divided by s cube plus y bar s divided by s square plus 1. So y bar s equals to 1 divided by s square plus 1 is equal to 6 divided by s. So y bar s equals to 6 into s square plus 1 divided by s cube. 6 divided by s plus 6 divided by s cube. Hence yx equals to 6 into L inverse cube plus 6 into L inverse. It should be, there is some mistake, is s to the power 5. So it is 6 x to the power 5 and 6 x cube. This is cube. So apply the formula 6 1 by s to the power 5 equals to 6 into x square by 2 plus 6 into x to the power 4 divided by 24. So it is 3x square plus x to the power 4 divided by 4. Now next is solve the initial problem. X1 dash equal to x1 plus 12 x2, x2 dash 3x1, x2 the initial condition x1 0, x2 0 equals to 1. So I write at first the equation x1 dash equals to x1 plus 12 x2, okay, x2 dash equal to x1 3x1 plus x2. So A equals to 1 3 12 and dx by dt equals to ax and x equals to x1 x2 so det a minus lambda I equals 1 minus lambda 12 3 1 minus lambda 0. So I get the value lambda square directly trace and element plus minus 2 lambda minus 35 equals to 0. Date element date A equals to minus 35. So lambda plus 5 into lambda minus 7 equals to 0. So lambda equals to minus 5, 7. So Ax is equal to lambda x. So I get lambda 1 x. Lambda 1 equals to minus 5. So I get 6x 6 12 3 x1 x2 equals to 0. So x1 plus 2x2 equals to 0 and 3x1 plus 6x2 equals to 0. So my eigenvalue is x1 equals to minus 2 x2 equals to x2. So eigenvalue easily get a into minus 2 comma 1. Next, then lambda 2 equals to 7. We get 12x2 is equal to 6x1 by calculation. How I calculate? Because my minus 6, 12, 3 minus 6, x1, x2 equals to 0. Then I get easily that x1 is equal to 2x2. So eigenvalue 2 1 x equals to minus 2c1 e to the power 5t minus 5t plus 2c2 e to the power 7t c1 e to the power minus 5t plus c2 e to the power 7t. Because I can write this way, x equals to c1 e to the power minus 5t into minus 2 comma 1 plus c2 e to the power 7t 2 comma 1. This way I can write. Okay, and after that c1 x1 comma 0 and x2 comma 0 equals to minus 2c1 plus 2c2 and c1 plus c2 equals to 0 comma 1, and after that I find out c1 equals to half and c2 equals to half by calculation, as c1 plus c2 equals to 1 and c1 equals to c2. So my x is minus e to the power 5t and e to the power minus 5t divided by 2 and it plus e to the power 70 plus e to the power 70. Okay, I hope clear problem. Next problem is very same type problem. Just x dash equals to minus x plus 2y and y dash equals to minus 2x minus y, and that implies x dash y dash minus 2 minus 1 and 2 lambda square, the according to the formula, plus 2 lambda plus 5 equals to 0, and lambda equals to minus 1 2i plus minus 2i. This is my lambda value. So a minus lambda I equals to lambda I x equals to 0. So this value is minus 2i 2 minus 2 minus 2i into x1 x2 equals to 0. So I get the value 2x1 plus 2i x2 equals to 0. So x1 equals to k and x2 equals to ik. So my is a k into 1 comma I. This is my k value, and after that mod of a minus lambda 2 I x equals to 0. Similarly, we get same eigenvalue I comma 1. This type of eigenvalue we get. So e to the power minus 1 plus 2i c1 1 plus I plus e to the power minus 1 minus 2i c2 I comma 1. Hello dear friends, welcome to my channel. Today's discussion is calculus part 2. Calculus part 2. Friends, I have already created calculus part 1 videos, and where I solved total 12 problems. Now I will discuss number 13 problem, question number. In this video I I try to explain total my target to create total 20 problem, to solve 20 problem, but I break my videos two part, calculus part 1, calculus part 2. So let's start discuss our problem. Given k x comma 2 is equal to x square and y is equal to x minus 0 to x 0 to x t square yt. Now yx is equal to fx lambda 0 to x k x comma t yt dt. Now fx is equal to x k x comma t equals to xt square and lambda equals to minus 1. k1 x comma t k x comma 2 x comma t equal to x square k2 x comma t equals to 0 to x x comma xt k x comma z k z comma t dz. So it can be written t xt into x z square z square into dz. That equals to xt whole square tx into z cube dz equal to x t square into x minus t it can be written z cube by dz. It can be written divided by 4 tx equal to x square xt square divided by 4 into x to the power 4 minus t to the power 4. k3 x comma t equals to a x comma z into k z comma t dz equals to t xt x square into z to the power 4 z to the power 4 t to the power 4 into z cube dz. So it can be written this way: x square divided by 4 t2x into z to the power 7 minus t to the power 4 z cube into dz. It can be written as x square by 4 by 2 factorial into x to the power 4 minus t to the power 4 whole square. Similarly, I can write km x comma t is equal to xt square divided by 4 to the power m minus 1 factorial into m minus 1 summation m equals to 1 to infinity lambda to the power m minus 1 km x comma t equals to x t square summation m equals to 1 to infinity lambda x to the power 4 minus t to the power 4 divided by 4 that implies xt square e to the power lambda x to the power 4 minus t to the power 4 divided by m minus 1 factorial. So I get 2 comma t. So now my yx equals to fx plus lambda 0 to x r xt comma lambda d lambda, sorry, it is not d lambda, is ft dt e to the power minus x to the power 4 minus t to the power 4 divided into t cube dt. Now x to the power 4 minus t to the power 4 divided by 4 equals to z. dz equals to t cube dt minus of this. So that I can write x minus x into 0 to first portion limit is 0 and second portion is x to the power 4 by 4 e to the power minus z dz equals to x yx equals to x into minus x e to the power 0 minus e to the power x to the power 4 by 4 equals to x into e to the power x to the power 4 divided by 4 minus. So y root 2 equals to root 2 e inverse. So my answer is root 2 e inverse. Now we are going to solve the next problem, problem 14. Which of the following are the characteristic number and the corresponding eigenfunctions for the Fredholm homogeneous equation? Kernel is a xt x plus 1 into t plus 1 into x, 0 less than x less than t and t x less than equals to 1. This is my so Fredholm equation, homogeneous equation. Fredholm homogeneous equation. Fredholm homogeneous equation yx equals to lambda a to b t kx comma t kx comma t yt dt. So consider yt equals to lambda 0 to 1 k x comma t yt dt. Yeah, there is yx dx. I can write this is yx dx. So yt equals to lambda 0 to to t x plus 1 into t into yx dx. And plus t to 1 t plus 1 x y x dx. 0 to t x plus 1 yx dx plus t plus 1 1 into t yt, because friends I apply integration, oh sorry, whatever I want to do, I I apply Newton Leibniz theorem. Just Newton. What I apply? I apply just formula, just differentiating Newton Leibniz theorem. So Newton Leibniz theorem is del f by del t is equal to phi into del phi by del t into dx. This is not phi. I can write this is g plus into gt minus phi t into, now apply Newton Leibniz theorem, del I by del t. Suppose I is equal to phi x, sorry, this is phi x and phi r, otherwise you can write it is hx into gx ft dt. Okay, I can write this way. After that I can write ddx del I by del x equals to ddx integration g x h x ft dt, and that equals to plus if gx into g dash x minus if hx into h dash x. So this is my Newton Leibniz formula. I apply in here. So I apply this formula in here. So I can write this equation in this way by the Newton Leibniz theorem, and p2 1 p plus 1 into x yx dx. It is not t plus y, so t plus y will be vanish, so it can be written only x yx dx minus t plus 1 yt. So this is my total formula. Now y dash t can be written as lambda 0 to t x plus 1 x plus 1 into yx dx plus t to 1 x yx dx. That I can write this way: y double dash t equals to lambda 0 to t 0 dx plus t plus 1 yt plus 0 minus t yt. So this equals to, I get lambda yt. So y double dash t minus lambda yt equals to 0. Where y0 equal to y0 equals to lambda 0 to 1 x yx dx and y dash 0 equals to lambda 0 to 1 x yx dx. So y0 equals to y dash 0. Now again we can prove that y1 1 equals to y dash 1 similar way. So that means lambda equals to 1. So y double dash x y double dash x minus yx equals to 0. So m square minus 1 equals to 0. So m equals to plus minus 1, and yt equals to a into e to the power t e to the power minus t, and y dash t equals to a into e to the power t minus b into e to the power minus t. Now just y dash 1 equals to y1. So we have b equals to 0. If you put, then you can get b equals to 0 as ae plus b inverse equals to ae minus be inverse. So that's why you can get b equals to 0. So when b equals to 0, so a is free variable. A is free variable. So yt equals to a e to the power t, and so take a equals to 1. So yt equals to e to the power t. So is 2 when lambda equals to minus pi square, then m equals to plus minus I pi. So yt equals to a cos pi t plus b sin t. So y dash t equals to minus a pi sin pi t plus b pi cos pi t. So y0 equals to y dash 0. So a equals to so yt equals to pi cos pi t plus sin pi t. So you can get again y double dash t equals to 4 pi squared y t equals to 0. So m equals to plus minus 2 pi I. So yt equals to cos 2 pi t sin 2 pi t. So I have cleared the concept. I will solve extremal problem. The extremal of the function gy is equal to 720 x square y and y double dash whole square dx subject to y0 y dash 0 y dash 1. So j y equals a to b and functional dependent on higher order derivative. So j y equals to a to b if x comma y dash up to y in dx. So the equation will become if y del x into if y dash d square y dx square if double dash plus, sorry, it is minus, after that minus 1 to the power n minus 1 to the power n ddn of d x to the power n if y n equals to 0. So I can write this equation. My f is, my capital F is 720 x square y minus y triple y double dash whole square. So this is 720 x square y. Sorry, it is y is not, minus 0 plus d square divided by dx square minus 2 y double dash equals to 0. So 720 x square minus 2 y equals to 0. So y 1/4 is equal to 720 x square and 2y4, and y4 equals to 360 x square. It is x is 120 x cube the c. So y triple dash and y double dash equals to 30 x to the power 4 plus c1x plus c2 and y dash equals to 6 x to the power 5 plus c1 x cube divided by x square divided by 2 plus c2x plus c3. Similarly, I get y equals to x to the power 6 plus c1 x cube divided by 3 plus c2 x square divided by 2 plus c3 x plus c4. This is my y. Y0 means 0, that is c4, because by boundary condition, friends, you see y0 equals to 0. Putting in here y0 equals to 0 and c4 y dash 1 equals to 6 equals to 6 plus c1 divided by 2 plus c2. So c1 plus 2c2 equals to 0. Overall, my yx should be x to the power 6 plus 2 x cube minus 3 x square, because you see that this equation is whole, because if c1 equals to 6 and c2 equals to 3, then this equation holds. So friends, I discuss this problem. Next, now we are going to solve next problem. Find the extremal of the functional I y x. So if x comma y dash equals y dash whole square y square plus 2xy. So del f by del y equals to minus 2y plus 2x, and del f by del y dash equals to 2y dash. So del f by del y equals to ddx of del f by del y dash equals to 0. That implies y double dash plus y equals to x. So now we see that y double dash plus y equals to 0. So m square plus 1 equals to 0. So m equals to plus minus I, and c1 cos x plus c2 sin x, and pi 1 divided by d square plus 1 into x equals to x, and y0 equals to 0 equals to c1, y equals to c2 sin x minus plus x. So c2 equals to minus pi by 2, putting the initial values. When x equals to pi by 2, it is given that x equals to pi by 2. So c2 and y equals to 0. Okay, this is my answer. Now we are going to solve extremal value problem. F is equal to solution. F is equal to 3xy and del f by minus 2y, and del f by del y dash equals to 0. So del f by del y minus ddx of del f by del y dash equals to 0. So we get 3x minus 2y equals to 0. So 3x equals to 2y. So y equals to 3 by 2 x. So x equals to, so y equals to 3 by 2. But in my question that when y equals to 1, then x equals to 1. But we see y equals to 1, that is 3 by 2. So no extremal values. No extremal values. Next, we are going to solve next problem. So friends, I left this question number 18. This is Lagrangian equation. can be solved Lagrangian equation I will solve, but my target to solve these questions. Question number 19. So if y is a solution of yx minus 0, x minus t yt dt, then of the following is true: y is bounded, not periodic in R, y is periodic in R, and this is. So how can I find out yx equals to 0 x into x minus t yt dt plus 1. Apply Laplace both sides. So Lyx plus Lt into y bar. Y bar is equals to 1 by s plus 1 by s square y bar s. So y bar s equals to s divided by s square minus 1 and L inverse y is equals to L inverse s equals to cos hx e to the power x plus e to the power minus x divided by 2. So it is periodic in C, not R, and limit extends to infinity yx equals to limit extends to infinity e to the power x plus e to the power minus x divided by 2 and equals to infinity, that is unbounded. Now in R, y x dx is also infinity. So this option is wrong, this option is wrong, this option is wrong. So only this option is correct. Because 2 into dx plus e to the power minus x less than infinity equals to pi by 2. Pi by 2 into 2 because it is 0 to infinity. 0 to infinity minus infinity to infinity. Question number 20. Let u be the solution of the problem u x x u y y is equal to 0, x comma y 0 comma pi 0 comma pi, u 0 comma y u pi y u x 0 u x 2 pi is equal to sine 2x. Then maximum u x comma y u x 0 comma 0 I have to find out. Now let's start. So here on the first option is correct. This option is true and other option is wrong. Now I will discuss the problem. How can I get the answer? U x comma y equals to summation n equals to 1 to infinity if n sin n pi divided by x into sin h n pi divided by a into y. It is y, it is 0, it is x, it is pi comma pi, and it is 0 comma pi. My diagram is not so much good, but I just try to explain all problem. So this is, and this boundary u x comma 0 equals to 0, and this boundary u x comma pi equals to sine 2x. Now a equals to pi and b equals to pi. U x comma y equals to summation n equals to 1 to infinity fn nx and sine h xy. As u x comma equal to sine 2x and sine 2x can be written this is my boundary condition u x comma 2 pi is equal to sine 2x. So I use this condition in here. So sine 2x equals summation n equals to 1 to infinity fn sine nx into sine h n pi. So it can be written f1 sine x sine h pi f2 into sine sine h 2 pi. So comparing both the sides only, both the sides only, 1 by sine h 2 pi. So Fy equals to sine h divided by 2 pi sine 2x into sine h2y. The maximum ux comma y 0 less than equals to x and y less than equals to pi equals to 1, that is belongs to the set is less than is less than is less than or equal to that value. So 0 less than equals to x less than equals to 2 pi less than equals to pi, sorry, 2x 0 less than equals to x less than equals to pi, and 0 less than equals to 2x equals to, so minus 1 less than equals to sine 2x less than equals to 1. Sine 0 less than equals to sine h2y less than equals to sine h2 pi. So it can be written this way: 0 less than equals to sine h2y divided by sine h2 pi equals to 1. Uxy equals to 1 by sine h2 pi. Sine x into sine h divided by 2y. Now initial value ux0 comma y0 equals to sine h2y divided by sine h2 pi. This value now max of u x comma y is greater than 1 and mean of u x comma y equals to minus 1. So my first option is correct, greater than equals to. Is it equals to 1? First option is correct. Second option is not correct. Now we'll solve this problem. P, consider P, capital P, plus Q, capital Q equals to R. Okay. Here dx, so my condition is dx divided by P is equal to dy divided by capital Q and dz divided by capital R. This is my Lagrange's equation. So I apply this formula. Whatever I get dx divided by x plus y into z equals to dy divided by x minus y into z equals to dz divided by x square plus y square. So now I can write this equation in this way. First I comparing these two factor, that is dx divided equals to dy divided by x minus y. Okay, now it can be written this way: x into dx minus y into dx x into dy plus y into dy. So it can be written x dx minus y dy equals to x dy plus y dx. So it can be written this way: d of x squared minus y squared into half equals to d of xy. So x squared minus y squared is equal to 2xy. Plus c1. Now again I want to solve this problem this way, that x dx plus y dy minus z dz equals to z into x square plus xy it can be minus xy plus y squared minus x squared minus y squared. So this portion cut, this portion cut. So into dx minus y dy. So the value is x squared minus y squared minus z squared equals to C2. So the formula is that Ci equal to F C2. Otherwise you can write phi Ci C1 C2 equals to 0. So it can be written this way. So C1 equals to x squared minus y squared minus 2xy equals to C1. So it is phi x squared minus y squared minus 2xy. This is my answer. I hope I can clear the total